let's do that. Okay. So 7. If you will notice, on your orange papers, just like on your neon green paper, I have been kind to you and provided you with some steps at the top to anchor us in our work. Some of you have started to realize, especially with continuity, that I'm giving you the steps for a reason. If you try to deviate from the steps, you're likely to not get full credit. They are there because this is what I am holding you to, and this is what I want to see every single time in as much detail as possible so that you can be 100% sure you're earning full credit. Just like with continuity, we have a template for IVT. In order to address College Board free response questions that assess the intermediate value theorem, we are always going to need to verify or prove that our function is continuous. Remember all of those scenarios yesterday, my weight in particular, right? The only reason it was guaranteed that I would hit all of those weights in between 7 pounds, 14 ounces, and what did I say, 200 pounds today, was because weight is a continuous function. Without knowing that, we throw out those guarantees, and they're not guarantees. So we have to be proactive here and state continuity first. Step 2 is to evaluate our endpoints. You will be given an interval, and your job is to verify what the first y value is and what the second y value is, so we know what window of y's it is that we are considering to prove about the existence of something in the middle. We have to verify our endpoints. And the third is a conclusion. Is it okay to forget your conclusion? No, we learned that, okay? And this one's yuckier. It is not as nice as therefore the function is continuous. Instead, it is. Since our function is continuous, the IVT applies. And since one endpoint is less than that magic number and that magic number is less than the other endpoint, then f of c will equal m at least once on our arrow. Many of you will try to say that not in mathematics, but in words. You will start writing to me, and you will say, well, because one endpoint's negative and the other one is positive, it's guaranteed that because one's above and the other's below, it's going to hit this somewhere in the middle. And you start talking or writing, and you don't stop. And oftentimes you write me a novel, and somewhere in that novel of things that I'll read it and I'm like, good, bad. You talk yourself silly until you say something untrue, and then you don't get points for it. So I prefer to see this. I know that's a lot, but get over it. Look alive. You tired? Stand up if you're tired. Yeah. 2009. Were you in middle school yet?
No.
Yeah, 6th grade. 6th grade, baby. Fifth, 6th grade. This is what they did to us on the AP exam in 09. P.S. They'll throw physics at us all the time because physics is immediately confusing. And sometimes when you read the word velocity, you're like, forget it, I'm done. But it's not that bad. The velocity of a particle moving along the x-axis is modeled by a continuous function called v when the position x is measured in meters and time is measured in seconds. Key word there? Continuous. This is when the College Board's in a good mood and they tell us the function is continuous. That's best case. Moving right along, selected values of velocity are given in the table below. You'll notice we've got times measured in seconds, we've got velocities measured in meters per second. For the time interval 0 to 40, must the particle come to rest in any of the subintervals indicated? If so, identify the smallest subintervals and explain your reasoning. If not, explain why not. This is how they love to do this. Generally in a physics setting like this, and they'll ask us, based on this data, is there any time when the particle was at rest? If I am at rest, my velocity is what? 0. This is just like yesterday, us asking if we'll ever have a time when we hit the x-axis. But the language is a little bit more higher level here. So will I ever come to rest is the question. Rather than me just answer this for you, I'd love for you to kind of facilitate some discussion amongst yourself. will the particle come to rest and how many times is what I just want to hear about. You don't have to write anything yet, but you can annotate your table. I'll find my phone and we'll put 1 minute on the clock for you. Sorry, Edgar. I really don't know where it is.
I think so, right? I think 1 and 32 to 40. Because the velocity like goes from a negative to a positive, we can assume there, and also from 8 to 20. Since that,
Yeah.
then
8 to 20 and then 5 and then 32.
it means from 8 to 20 and 32. Yeah.
Where? Between what? Thank you, Karina. Here it slows down.
So do we need 40? That's positive.
Okay. David, how many times? 2. Must the particle come to rest? I would say yes, the particle must come to rest twice. And let me be really clear, at least twice. Could come to rest more than that, but at a minimum, it's going to come to rest 2 times. And what David and Edwin and these guys were telling me about here is that it's going to happen right in here between 8 seconds and 20 seconds. And it's going to happen somewhere over here between 32 and 40 seconds. What were they noticing about these 2 boxed up intervals that leads us to believe that we will come to rest somewhere in these places? Yeah.
Goes from positive to negative.
Yeah. Our function changes from positive to negative or negative to positive in those intervals. And just by nature of numbers, that means we will cross 0 in the middle. Good? So this is pretty intuitive. Like you can see this from the data here. And if you are not careful, you could get no credit for this question, which is really sad because I think we all know it's going to happen twice between 8 and 20 and 32 and 40, but without being really clear, we get no credit. So according to our template up there, we are told to first state or prove continuity. This is the step most students forget in the heat of the moment on a test. They're just like, oh yeah, positive, negative, done. And you never tell me the function is continuous. And we saw those counterexamples yesterday that would throw that out the window. So step 1, v of t is continuous on the interval 0 to 40. Guess what? Because they told me that, I don't have to do anything else except restate. They shared with me, thank the Lord, that continuous was the kind of function that I had. Don't do anything else. You can throw things if you want. Number 2. Endpoints. We need to evaluate f of A and f of B. Now I want to be really clear right here. That does not necessarily mean I want to evaluate f of 0 and f of 40, because that's not helpful. That would mean I'm looking at a y value from 3 to 7, which doesn't capture 0. But in this specific instance, it's going to be helpful for me to show what f of 8 and f of 20 are equal to, and what f of 32 and f of 40 are equal to. And I'm saying f, that's so bad. What is this function's name? B, right? However, showing those endpoints is going to lead directly into the conclusion statement that I'm about to make that your intuition led you to earlier. So what I want to do right now is show that v of 8 is equal to 5 and v of 20 is equal to negative 10. Here I am really pinpointing and zooming in on a region or an interval where I must hit 0. And perhaps you could guess, I also want to write down the other two places that are significant for that, for this question. V of 32 equals -4, and V of 40 equals 7.
That was dramatic. Okay.
A lot of students will write those down and do some annotation, like, or maybe point or something, like must, cross, 0, right? So that we're annotating exactly why this is significant. You don't have to, but that's helpful if you want to see it. Okay, and then the third step in an IBT free response is to write a conclusion. That conclusion can vary based on what your question is asking you to identify. So the first question here, must the particle come to rest in any of the subintervals indicated? Yes, we must come to rest at least twice. And the second question says, identify the smallest subintervals and explain your reasoning. So we're going to come to rest between 8 and 20 and between 32 and 40 here. And that's what my conclusion statement is going to try to address. Are you ready? Say yes.
Yes.
Zoe. Since V of t is continuous, IBT applies. You want to tell the reader that you know what you're talking about, that you know this is the intermediate value theorem that we're applying to make these conclusions. Since, and here's where I'm going to stray a little bit from my template because this is very generic and I'm going to make it super specific to this problem. And I'm going to do it twice because I've got to show from the 8 to 20 and the 32 to 40. So since V of 8 is less than 0 and that's less than V of 20. Are you with me here? Then V of C, that can be generic, will equal 0 at least once on 8 to 20. This is exactly what you guys would say to me out loud, but written in a mathematical way. I need to say this again, yes, for 32 to 40. Some of you are really good at like compound sentences or complex sentences. I don't know, I don't teach English. And you will put it all in one big run-on, which is fine. We don't grade grammar, we just grade for like accuracy of what you're stating. Others of you will just want to write another sentence, which is fine. I'm just gonna write a second sentence over here. Since, but I have to be very careful with the conclusion that I write right now. If I'm a robot, which some of you are, and you don't think, you're just like robotic and you repeat steps, you'll write V of 32 is less than 0 is less than V of 40. And that is fundamentally untrue. V of, no, wait, that's true. The one we wrote back there was untrue. And nobody said anything. Let me finish this one and I'll go back and fix it. This is true because V of 32 is the negative number, right? And V of 40 is the positive number. So this order makes sense, that one doesn't. I'll go fix it. Since that inequality holds, V of C will equal 0 at least once on 32 to 40. Let me let you write that before I go back and correct myself over here. If you hone in on this inequality right here that I started with, here's where the problem is, right? V of 8 is what kind of a number? Positive. And is a positive number less than 0? No. So if I had been more careful, I should have recognized that the first go around and swapped the order of my inequality. Or if that bothers you and you want to see the less than, so no matter what, you would have had to trade the V of 20 and the V of 8 and lead with the negative number. But now that's true. If you want to be really fancy and impress the people, you could put a C1 over there and a C2 over here to indicate that this is happening at a couple of places. You don't have to.
You have to put DT.
No. Because it's for some value in that function that we will equal.
Oh, okay.
Cool. Good question. All right. Let's try another one without all of my support. Come down here to problem 1. That was our model. You have data. You're given some info. I'm going to be quiet. Edward's going to put, let's do 3 minutes to analyze, think through it with common sense, and then try and formulate your answer with mathematics. And Zosimo, cut.